So the next section we're going to look at is dealing with the properties of the logs. So we have the properties for logarithms and the properties for natural logarithms. You'll notice that they are pretty much identical. Just one uses log, one uses ln. Keep in mind, ln is still a log. It has a base of e. We just write it as ln and not log. So, what these properties help us do is either expand logs, so make them bigger, or condense them, make them smaller. So, the left side here, this would be considered the condensed version of these logs. So, I'm going to put a C for condensed. This side, they are expanded. So, I'm going to put an E for expanded on this side. So, condensed means it's one single log. Expanded means we have multiple logs. So if we have the log base, say, of u times v, so if we're using multiplication with these terms, we would use addition when we expand. So u gets a log with the same base as what we have here, so log base a of u, and then we're going to use addition to split this up since we started with multiplication. Once again, v gets its own log. So when we expand, we make it bigger, we use addition, and we give everything its own log. For number 2, we have the log base a of u divided by v. So once again, we're one single log. So to split this up, we are going to now use subtraction. So division goes with subtraction, multiplication goes with addition. So once again, the u gets its own log and the v gets its own log. Make sure that you carry the base to both. This last property is taking an exponent. So in condensed form, we have an exponent on our base. In expanded form, we can bring the exponent in front of the log. So that is the last property that can go from condensed to expanded. So once you have those written down, we're going to move on to some examples. So this example says use properties of logs to expand each expression. And so I have this picture of Oprah Winfrey over here. It says you get a log and you get a log, and every variable gets a log to remind you every single variable, every part of your expression gets its own log if we are expanding, if we're making it bigger. So every part of this is going to have its own log. So the first thing we're going to do is we're going to start by giving everything its own log. So that's step number 1. Every one gets a log. That is our first step that we're going to do. So since we're using log base 4, we want to keep with that. And we're going to do the log base 4 of 5 plus the log base 4 of x to the third plus the log base 4 of y. So I expanded it out fully. The next thing we want to do, so step 2, bring exponents in front. So the only exponent I have is this one right here. So this 3 needs to come in front of that log. So we write everything else the same. The log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And so that would be my final step. So notice, since this was multiplication, I used addition. I had 1, 2, 3 things being multiplied. So I have 1, 2, 3 separate logs. And that is how we expand that expression. Now, if we want to take a look at this example, so this was A. I'm going to put B down here. We're going to do the same thing. So the first thing we're going to do with this, everyone gets a log. So what I mean by everyone gets a log is that if you have something like this, 3x minus 5, we can't split that up. So you have to think of that kind of like it's a factor. So this piece gets its own log and 7 gets its own log, but we can't split up 3x minus 5. So that whole part needs to stay together. Since we have division, we are going to now use subtraction in between our logs. So since we have ln, we're going to use ln here. Ln of 3x minus 5 minus ln of 7. And like I said before, we can't split this up because of this minus sign, these two terms go together. And in this case, we don't have any exponents, so we can just move on. Now condensing or making it smaller, turning it into one log is going the opposite way. So we are now going to do these steps in reverse order. So first we're going to bring the exponents that are in front to be exponents. So bring numbers in front as exponents. So numbers in front become exponents. Whoop, become exponents. And then the second part is we write everything as one log. So those are going to be our steps when we are condensing. So here we have 1/2 in front and we have 3 in front. So those need to become exponents. So since we're using the log base 10, we write the log base 10 of x to the 1/2 plus log base 10 of x plus 1 to the 3rd. So I didn't change anything just yet. All I did was bring the numbers in front to be exponents. So now, since we're using addition, we're going to write it as one log, log base 10. And addition means we're going to multiply. So x to the 1/2 is the same thing as square root of x. So that's how I'm going to write it to, fully simplify it. And I'm going to multiply that by x plus 1 to the 3rd. This looks a little bit funky, but that is fully condensed. And we can leave it like that. So that's A. Now we're going to take a look at B. So taking a look at B, we have 2 in front here and nothing in front there. So first step, move the numbers in front to become an exponent. So 2 needs to become an exponent. And then the next thing we're going to do is combine these logs to be 1. So we're going to use ln. We have subtraction here. So we are going to use division. X plus 2 squared over x. And now we are done. We condensed it as one log.